I'm going to try to create a Minesweeper program as quickly as possible. And then I'll explain a little bit more at the end with the details. So first I'll hit start on my timer, and I'm going to create a matrix or a list of lists to represent the board. So my board, I'm going to start out with a 5x5 board, but you certainly could make the dimensions of your board whatever you want. So this would just be one row. I want actually 5 of the rows, so I'm going to copy and paste. So my board will look like 3, 4, 5. All right, that's the board, and I'm going to put a comment in here saying this is the board that the user cannot see, or the solution. We can copy and paste and make another variable to represent what the user's actually seeing. So this one is what the user can see, and instead of, you can't have 2 variables with the same name, so I'll call this board display. Instead of having zeros here, I want these all to be -1. And there's a reason for that. I'm going to end up using some math to count up how many bombs are around different positions. So adding a 0 means there's no bomb. And so I'll put that in my little key here. So 0 equals no bomb. A 1 would be a bomb. And then -1 means you just haven't even looked in that position yet. So -1 is an unknown, or a spot that you haven't looked at. So let me copy and paste this 5 times. The timer's kind of throwing me off here. Adds unnecessary pressure. And all right, so we've got what the user can see, the solution, and now we want to randomly add some mines. I'm going to add 1 mine first, and then we can make a loop to add more than 1 mine. So the number of mines, we could let the user decide whether they want to do a difficult or an easy version of Minesweeper. So I'm going to ask them how many mines do they want. And I'm going to change their input to an integer, so I can use some math and some comparison with an int. If they give me something that is greater than 25 and it's at 5x5, then there's not enough spots to have more than 25 mines, so I'm going to print that is impossible. And instead of ending the game right there, I'm just going to set that to 5 as the default. And so number of mines is equal to 5. All right, so to randomly place a mine in there, I'm going to import the random module. And the random module will let me pick a random integer. I'm going to say, so the row you want to put the bomb in, we'll do random randint, either starting at row 0 or all the way to row 4, somewhere in there. We're going to randomly pick our row, and same thing for the column. So copy and paste that. Only we'll change the variable name to col for column. All right, so here's where I want my mine to be. And then eventually we're going to be adding more than 1 mine, so we would want to check, is the spot that we selected something that already had a mine in it, in that case we're not going to add a second mine to a spot. So I'm going to be checking if the spot's 0, then that means there isn't a mine there yet, and we are safe to add one. And to add a mine, all we do is stick a 1 there. So add a mine. We'll start with just 1 mine, and then I want to display and see what my board looks like. So I'm going to write a function, display solution. And this relies on the global variable. So I'm going to do for all the rows in the range of 0 to 5. Here I have to go 1 beyond. with the range command, it stops before it gets to the 5. So I'm going to go 1 beyond there. And it'll go 0 to 4 is what it'll actually print. Ooh, instead of copying, I ended up deleting. I want to copy this line and do the same kind of thing for each of the rows and the columns. So for each row and each column, we want to go ahead and print out the solution for debugging of what is actually at each row and column as far as mines. And this little end is equal to thing means don't go to the next line, stay on the same line. And I only want to go to the next line if I've finished printing everything for each row, every column in each row. So we've definitely done enough code. We need to actually run it and see what's happening. So I will display my solution right now. And when we run it, our board that starts out with a bunch of zeros, if I say I want 4 mines in it, then, oh, I actually didn't call that, I added 1 mine. I randomly picked where I wanted the mine. So we're gonna go ahead and hit run again. It doesn't really matter what I type in here, except if I do something more than 25, it should set it back to 5. But I need to call this function, or call this part where I'm adding a mine, num mine times. So I'm gonna say while, well, actually, here's the number of actual mines. Okay, so the number of mines, and while the num variable is less than num mines, keep doing what we did here of adding a single mine. And we'll need to increase our counter, saying every time we added a mine, increase that by 1. Okay, run it one more time. And how many mines? Let's do 6. 1, 2, 3, 4, 5, 6. And so it's randomly selecting those spots for the mines. All right, so this is a good start. We need to display, not the solution, this was just for debugging. I'm gonna clone my display solution, and instead of displaying the board with all the solution, I wanna display, paste, oh, that's not right. My copying and pasting skills need a little work. Let's paste this here. Instead of displaying the solution, I want to display the board of what the user actually has guessed so far, and the thing that has the number of showing how many mines are around it. So I think my other variable was called board display, so we're going to call this board display. And in this case, I'll display the solution for our debugging, and then I'll display the board as the user sees it in between each of their guesses. But instead of a bunch of -1s, I want to say if it's a -1, you're going to just see a space. So if board display row column is equal to -1, then we're just going to print a space. And again, I'm going to actually try to make this a little bit fancier and show like a grid around each of the positions. So we've got, after each number, I'm going to display a space and a slash. We'll go ahead and see how this looks. See if that looks a little bit nicer. Okay, so at the beginning they haven't guessed anything at all, so they see a bunch of blanks. We could even, I'm gonna put a line at the beginning of this, and at the end of each line. I'm just doing a hyphen there 21 times. I'm just trying to guess what is going to go all the way across. Okay, that looks pretty nice. Good enough. We could use a couple more. Before each row, at the beginning of each row, let's go ahead and also print one of these. And maybe a space there. I think that looks pretty good. One more time. Okay, but I need to get into the user playing the game. So we've displayed the empty board, and now I need to ask the user where they would like to go, what their guess is. So I'll make a variable guess. I'll say they've had 0 guesses at the beginning. So the game will end when they've done every possible guess and they still haven't hit a mine, or when they've hit a mine. So if the guesses, or the guesses, yeah, this is the number of guesses. If that's less than 25, but really they can't do 25 guesses because some of those guesses would mean they hit a mine. So 25 minus the number of mines, that's the maximum number of guesses they could do. So while they still have guesses left, we'll ask them to guess a row. And I'm going to have the user type between 0 and 5 because humans think in terms of 1 as the beginning row, even though computers may think of it as 0. So we've got our guess for the row, and we'll also have a guess for the column. And now we see if they've hit a mine. So if the real board, the solution board, at the row and column position has a 1 in it, that's one of those randomly selected spots where we put a mine. So then I'm going to print, boom, you know, you hit a mine. And this would be the ideal time to show them the solution. So then I could display the solution. I forget the exact name of that function. Yeah, that's what it was. Else, if they didn't hit a mine, then we actually need to do a little bit more work. So I'm going to call, I want to say the spot that they guessed, the row and the column that they guessed, we need to actually figure out what number should be displayed there. So the number of bombs around that spot. So I'm going to check mines around. So a very long function name, check around the rows and columns so we can know what number is supposed to be there, update the board with that number, and then display your board. Okay, I paused the timer to get a charging cable. My Mac was almost out of batteries. So let me restart the timer. And where were we? Okay, we need to write a function to figure out how many mines are around the spot that we guessed. So it's going to be a brand new function. We can put it anywhere here. It's going to be, again, because I'm trying to save myself time, I'm going to be using global variables inside this function. So I'm going to call my function, we're defining a check mines around function, and we're going to check around this row and column, and T for total. I'm getting a little sloppy with this one letter abbreviation variable names. So this will be the total mines around this spot on the board. And then just another little variable to keep track of which row we're looking at. And while this I is less than or equal to the row that they selected plus 1, I'll do a diagram and explain this function. This is probably the most complicated part of the program, but I will describe this after I stop the timer. So we're going to look if we're in between the spots of 0 and 4. That's a legal spot that we could be checking. And then we're going to look in the rows and columns around it. Let's say if this is also between the boundaries that are legal on the board, then by doing the total of bombs that we found so far is our T variable, our 0 plus, and then because every bomb has a 1, then adding this spot is either going to add a 0, meaning there wasn't a bomb, or a 1, meaning there was a bomb. So by calling over and over and adding every board ij all the way around the spot that they were looking for, we're going to add up the total number of bombs so far. So after this, so we don't get an infinite loop, we need to make sure to increment our loop counter variables. So I had an I and a J, which I could have had more descriptive variable names for sure. So at the end of this function will return the total number of bombs around that spot. All right, let's go ahead and run it and see if I made any mistakes. All right, how many mines? Let's do 4 mines. I'm going to purposely guess this spot 1, 1, and I can see there's 2 mines around it. Oh, okay. I said that the humans want to put in a 1 through 5, but if I want to do that, then I need to subtract 1, so it turns into a 0 and 0. So instead, I ended up guessing row 2, column 2, and I got a 4, which ends up, is that right? So if I guess here 1, 2, 3, 4, yeah, that is the right number. So I think my code actually might work after I put this in. Let me hit a bomb and see. So there was a bomb right to the left of that. So row 1, column 0, boom, you hit a mine. Okay, so I'm going to rerun this with my changes so that the user doesn't have to type in 0 through 4, they type in 1 through 5. How many mines? Let's say 5 mines. I'm going to guess 1, 1, 1, 2. There's 1 mine, I can see it, 1, 3. I don't know if I want to play this all the way through. The first row was good. I'm going to say I think I can stop my timer, and I should either finish this or hit a mine so I can end the while loop, and then I want to break down that one complicated function. So let's see, row 2, column 3 is going to hit a run. 2, 3, we hit a mine. Okay, so I stopped the timer. All right, let's really break down this check mines around function. So you've got this board right here, and you're passing into the function a row and a column. And so let's say you're curious of what number should be displayed when somebody selects this spot. So which means you want to count all the bombs in any of the squares touching this square. So anything in this square right here. So to call this function and check around this question mark, you would be passing in a row of 1 and a column of 2 to say, I want to check all the way around there. And the way that this function works is, I'm just going to pick another color, is it has some variables to temporarily keep track of what row and column you're on. And I picked I and J, probably could have picked R and C to tie them in with the rows and the columns. If the position where you're curious about is 1, then you want to subtract 1 from that row, meaning the very first row you're checking with has to be this top one up here, or row 0. And if you're on column 2 and you subtract 1 from that, that's the subtracting 1 down here, your J needs to start over here at 1. So column 1, this one right here. So this is the very first spot that we're looking at. And if there's a big 0 there, then you're adding to your total bombs a 0 plus a 0, so it's basically just going to be 0. We haven't made a change. Oops. We haven't made a change in that case. We've just got 0. Okay, but let's say the second place we check, so every time through this inner while loop, we're looking at a different column. So instead of our J being 1, the second time through the inner while loop, we're looking at this position right here. Let's say there's a bomb there. Well, now we're going to end up adding that number 1 that signified a bomb to our total, and our total is now going to be equal to 1. All right, and the next place we're going to check, let's say there's a 0, and we know that we do not have to check any farther because we have reached the point where we're 1 past the column that they were interested in. So we're done with that while loop. We go down here, increase our I by 1, and now we're ready to check the next row and check this spot. And if there's a 0, we'll add a 0 to the total. If there's a 1, we'll add a 1 to the total. We are actually adding in this spot itself, but we know 100% for sure that it's a 0, because if it was not a 0, we would have hit a bomb and we wouldn't have been calling this function at all. So we end up checking our second row. Let's go back here, and let's say maybe there's a 1 here, and erase some of this. Chicken scratch. And so now we've got our total. We've seen 2 bombs so far. And then we check the next row. And if we see another bomb, we're going to add in and say, well, instead of 2, now we've got 3 bombs. So at the end of this function, we're going to return the number of 3. That is how many bombs are around the spot in question. And on our display board, we'd end up putting a 3 right here. The display board is different than our regular board, so it wouldn't have all these other numbers. It would just say, well, you ask about this one spot. I'm going to tell you that this one spot has a 3 in it. Okay, so hopefully that broke down some of the mystery behind this function. I'm going to let you go. Happy programming.